Okay, so this is going to be a summation of what limits are and kind of basic stuff you should need to know. And if you're looking for how to solve a problem, that's going to be somewhere else. This is more what's going on. So a little diagram I have here in my notes is pre-calc, the limit process, and then calculus. So this is kind of the idea that calculus is based off of, is finding a limit. So what is a limit? It's represented by the notation limit as delta x approaches something. It could be, so we'll say C, a number. Our teacher tells us that usually when the number is close to the beginning of the alphabet, then it's going to be a number very soon. And this equals the limit definition, which is f of x plus delta x minus f of x over delta x. Basically, what this means is on a graph, kind of, if you've got a line, if you're going to 3, what number does x, so what is the limit as the change in x, delta x approaches 3? Well, the answer is 3 for this line. What number does it get to? What number does this get to as it approaches and gets arbitrarily close to this number? So to solve them, you just plug in this number. Now, and that's where the first way to solve them is. And so there's really the steps 1, or step 0, or step 1, direct substitution. And this is where you're just going to put this number, put the C number into your equation, whatever that is. If that doesn't work, you should, step 1, factor and reduce. Because what's going to stop this from happening, because if you have a limit, as if delta x approaches 0, and you have 1 over x, you can't do that because we can't divide by 0, so direct substitution is out, so we're going to move to factor and reduce. Not going to work here, it's pretty simple. So then 2, or step 3, rationalize with conjugate. And this still really isn't going to work. You can multiply by x on top. And then, but you're just going to get x over x squared, which would be 0 divided by 0. It still can't happen. So this case is a case where there is no limit, which I'll get into conditions for not a limit later. But for right now, so if we were finding the limit as delta x approaches 0 of x squared, well, we plug in 0, it equals 0. So the limit equals 0. It's pretty simple there. And then the last way, 1, 2, 3, or step 4 would be trig limits. And this is for your trig stuff. So that's why the pre-calc portion is so important, so you know all the stuff that you can use when you have trigonometric stuff in there. Another thing to know about limit notation. So limit delta x approaches, we'll say 3, and then we put this little minus here, which means from left, or from the left. And then if it's the limit of delta x as x approaches 3 with a plus sign, it just means from the right. And so that's basically all I'm going to cover here in Limits Part 1. Thanks for watching.